Hello everyone. In this tutorial, we are going to discuss a case study on ER diagram. Okay. So this ER diagram part is covered in week 4. Okay. So before watching this tutorial, I recommend you to go first watch those week 4 content and then see this tutorial. Okay. So now let's start. So first we will see what is an entity. Okay. An entity is a thing or object in the real world that is distinguishable from all other objects. Okay. Say for example, student is an entity. Okay. Say for laptop is also an entity. Okay. Say for example, bank is also an entity. Okay. Now this entity has several attributes, like student entity having attributes like name, roll number, age, and so on. Laptop may have different attributes like date of manufacturing, operating system, and so on. Okay. So an entity is represented by a set of attributes. Okay. An entity set is a set of entities of same type that share the same properties. Okay. So that share the same properties or attributes. Say for example, student is a different entity, laptop is a different entity. Okay. If we combine the student and laptop, will they able to form an entity set? No, because they have different properties. Okay. So for entity student, name, roll number, age are the set of attributes. Similarly for entity laptop, date of manufacturing and operating system are the attributes. Okay. So I hope you understand the difference between entity and attributes now. Now what is relationship? So a relationship is an association among the several entities. Okay. Say for example, here bank. Okay. So this is another entity, that is customer. Okay. So now the relationship between the bank and the customer is financial transaction. So say that is financial transaction. Okay. So the relationship between the bank and the customer is financial transaction. Similarly, the relationship between the student and the laptop is, say suppose, purchasing. Okay. Now purchasing. Okay. So the relationship between the student and the laptop is purchasing. So it means student can purchase many laptops. So there is many to many relationship. Okay. So we will see this mapping cardinality and these symbols later. Okay. So now let us discuss about mapping constraint. Okay. So this part is covered in week 4 by professor. Okay. So I will quickly go through it now. So here instructor and the student table is there. Okay. So here it indicates many to many relationship. Okay. Similarly here the relationship between the instructor and the student is 1-to-1. So basically if you see an arrow here, it means 1, and if there is no arrow, it means many. Okay. Similarly here also the relationship between the instructor and the student is 1-to-many. Okay. So my arrow indicates 1. 1 means at most 1, means either 0 or 1. Okay. So it is at most 1, and here there is no arrow means many. Okay. Similarly here also many to 1 relationship. So now see here that this double line indicates the total participation. Okay. Means there is total participation of student in the relationship advisor, and the single line indicates the partial participation. Okay. So I hope you understand this concept. Okay. Now we will see some symbols which are used in ER diagrams. Okay. So first is entity class. So entity is represented by an rectangle. Okay. A weak entity class is represented by a double rectangle. Okay. So what is a weak entity class here? So basically it is an entity set which do not have sufficient attribute to form a primary key. Okay. Means it depends on another entity for its existence. So for example, let us take one example of share market. Okay. So there are two entities, that is shareholder table and nominee table. Okay. This nominee table has the details of a nominee which belongs to a shareholder table. Okay. So now if the shareholder table is deleted, then there is no significance of this nominee table, means it is completely depend on this shareholder table. Okay. So that's why it is weak entity set. So we represent it by a double rectangle. So now, okay, so now what is relationship type? Okay, we already discussed this. So relationship is represented by a diamond shape. So an identifying relationship is represented by a double diamond shape. Okay. So what are the attributes we already discussed? So it is represented by an ellipse, and key attributes are represented by an ellipse with the underline. Okay, so discriminator and partial key attributes are represented by an ellipse with the dotted line. So basically partial key is used to represent weak entity class. Okay, so now what is derived attribute here? Okay, so derived attribute is represented by an dotted ellipse. So what is derived attribute now? Say for example age. So age is an derived attribute. Okay, so it is derived from date of birth, right? So why do we need this derived attribute? Because say suppose for example there is student table, okay, and it has two columns, that is name and age. Okay, so there are three entries and here 21, 23 and 19. Okay, so now in 2021 I need to find out the name of a student whose age is greater than 21. So I can easily find out that, but can I use the same table in 2025 also? So if I want to find out the name of a student who's having the age greater than 21 in 2025, does this table have any significance? Right? No. So that's why age is a dynamic attribute. So it is derived from date of birth. Okay. So I hope you understand the concept of derived attribute here. Now what is multi-valued attribute? Okay. So basically multi-valued attribute is represented by a double ellipse. So for example, phone number is a multi-valued attribute. Okay. So now what is composite attribute? So for example, address. So address is a composite attribute. It consists of PIN number, street and landmark. Okay. So this address is a composite attribute. I hope you understand the basic difference between the attribute, what is entity class and how it is represented. Okay. Okay, so now there are a few steps which we have to follow during our ER diagram part. Okay, so first we need to identify the entities in ER diagram. Okay, then after identifying the entities, we need to add the attributes to each entity. Okay, then we need to identify the relationship between the entities, and after that we need to add the cardinality to every relationship. Okay, we will follow this step during our case study also. So now we will discuss this case study. Okay, so here the prescription RX chain of pharmacies has offered to give you and your two neighbors a free lifetime supply of medicine if you design its database. Given the rising cost of healthcare, you agree, and here are the requirements. Okay, so based on this requirement, we have to draw our ER diagram. So we will see this one by one. Okay. Okay, so here is our case study. So based on this requirement, we have to draw our ER diagram. Okay. So we have to follow those four simple steps. So which one is our first step? So first we have to identify the entities, right? So now see here, patients are identified by an SSN and their names, address and ages must be recorded. Okay, so here patients is an entity set. Okay, and SSN, names, address and ages are the attributes of entity patients. Okay, so let us draw one rectangle here now, because entity is represented by an rectangle. Okay, so our entity is patients, right? So our entity is patients and it is having four attributes, and attributes are represented by ellipse. So we have to draw four ellipses here. Okay. Okay, so patient having four attributes, that is SSN, name, right, age, address. Okay, now here patients are identified by an SSN. So SSN isn't key here. So we have to underline this SSN. Okay, so now we have to link this attribute to the entities by drawing a single line. Okay, so here we have linked the attribute with the entity's patient. Now, doctors are identified by an SSN. For each doctor, the name, specialty and year of experience must be recorded. Okay, so our entity is doctors and attributes are SSN, name, specialty and year of experience. Okay, so we have to draw one more rectangle here. Okay, so it represents doctors, right? And it is having 4 attributes. So we have to draw 4 ellipses here. So 1, 2, 3 and 4. Okay. Oops. Now doctors having attribute. Now doctors having attribute SSN, name, specialty and year of experience, right? And here SSN is a key, so we have to underline that, and we need to link this attribute to the entity. Okay, so here patients and doctors are the entity, SSN, name, age, address are the attributes of entity patient. Okay, so now every patient has a primary physician, every doctor has at least one patient. Okay, so here every patient has a primary physician, so the relationship between the patient and the doctor is primary physician. So we need to draw one diamond shape here because it represents relationship. The relationship is primary physician, right? So primary physician. Okay, and now here every patient has a primary physician, means there is total participation of patients in the relationship physician. So we need to draw double lines here. Okay, and now here every doctor has at least one patient, means there is many to one relationship between the patient and the doctor. Okay, so we need to draw arrow here, so it represents 1, that is at most 1. Okay, so now doctor prescribe drugs for patients. Okay, so one more relationship between the doctor and the patient is prescribe. Okay, a doctor could prescribe one or more drugs for several patients, and a patient could obtain prescription from several doctors. Okay, so first we have to draw one diamond shape here. So the relationship between the doctor and the patient is prescribe. Okay, so see here, a doctor could prescribe one or more drugs for several patients, and the patient could obtain a prescription from several doctors. So which kind of relationship is this? That is many to many. Okay, so the relationship between the patient and the doctor is many to many for relationship prescribe. Okay, I hope you understand this concept. Now, okay, so here each prescription has a date and a quantity associated with it. So date and quantity are the attributes of relationship prescribed. So we need to draw 2 ellipses here. Okay, so the attributes are date and quantity, right? And we need to link this attribute to the relationship, right? Now you can assume that if a doctor prescribes same drug for the same patient more than once, only the last such prescription needs to be stored. Okay, so we will see this later because we will be required here entity drug. Okay, so now here each pharmaceutical company is identified by name and has a phone number. So one more entity here, that is pharmaceutical company. Okay, and it's identified by name and has a phone number. So let us draw one more rectangle here, that is pharmaceutical company. So that is pharmaceutical company, and it is having 2 attributes. Okay, that is name and phone number, right? So that is name and phone number. Okay, so we need to link this attribute to the entity, and here pharmaceutical company is identified by name. So name is a key here. So name is a key here. Okay, so now for each drug the trade name and formula must be recorded. Okay, so one new entity here, that is drug, having attribute trade name and formula. So let us draw one rectangle here, that is drug. Okay, now it is having 2 attributes. Which are those attributes? trade name and formula. So we need to draw two ellipse here, right? Okay, so one is trade name and other one is formula. Okay, so that is formula. Now each drug is sold by a given pharmaceutical company and the trade name identifies a drug uniquely from among the products of that company. If a pharmaceutical company is deleted, you need not keep track of its product any longer. Means this entity drug is completely dependent on this pharmaceutical company. So that's why drug is an weak entity set, right? So we need to draw double rectangle here. Okay, so weak entity set is represented in double rectangle. Okay, so now each drug is sold by a given pharmaceutical company and the trade name identifies a drug uniquely from among the products of that company. Okay, so now the pharmaceutical company makes various drugs. Okay, so the relationship between the pharmaceutical company and the drug is make, made or anything. Okay, so let's say make. So pharmaceutical company makes several drugs. Okay, so now each drug is sold by a given pharmaceutical company and the trade name identifies a drug uniquely from among the products. So names identified a drug uniquely means for a weak entity set, trade name is a partial key. So we need to represent by dotted line. Okay, and like the relationship make, identifying the weak entity is also an identifying relationship that is represented by a double diamond shape. So we need to draw here double diamond shape. Okay, and now there is total participation between the entity drug and the relationship make. Okay, and the trade name identifies a drug uniquely from among the products of that company. Means there is many to one relationship between the drug and the pharmacy. Okay, so here it is 1, so it is represent many to one. Okay, I hope you understand this concept. Now moving back to our this sentence, you can assume that if a doctor prescribes the same drug for the same patient more than once, only the last such prescription needs to be stored. Means there is many to many relationship between the doctor and the drugs for a relationship prescription. Okay, so we need to draw this one line here. Okay, to connect the relationship prescribed with the entity drug. Okay, now each pharmacy has a name, address and a phone number. So one more entity here, that is pharmacy, and having attributes name, address and phone number. So we need to draw one rectangle here, that is pharmacy. Okay, and it is having 3 attributes. So we need to draw 3 ellipse also. Okay, so the 3 attributes are name, address and phone number. Okay, so it is name, address and phone number. Okay, now pharmaceutical companies has long-term contracts with pharmacies. Okay, so here contracts is a relationship between the pharmaceutical company and pharmacies. Okay, so we need to draw one diamond shape here that represent relationship contract. Okay, so that is contract. Now a pharmaceutical company can contract with several pharmacies and a pharmacy can contract with several pharmaceutical companies. Means there is many to many relationship between the pharmaceutical company and pharmacy. Okay, so let us draw line here. Let us connect relationship with the entities. Okay. Okay. Now, for each contract, you have to store a start date, end date, and the text of a contract. So there are 3 attributes for a contract. Okay. So let us draw 3 ellipse here. Okay. So contract has start date, end date, and text. Okay. Now, pharmacist appoints supervisor for each contract. Okay. So one more attribute here, that is supervisor for contract. Okay. And there must always be a supervisor for each contract, but the contract supervisor can change over the lifetime of the contracts. Okay. So it is already a many-to-many relationship between the pharmaceutical companies and pharmacy. So we need to draw here one more attribute, that is supervisor. Okay. So that is supervisor. Okay. So now we need to link this attribute with the relationship contract. Okay. I hope you are getting this. Now, each pharmacy sells several drugs and has a price for each. So pharmacy sells several drugs and has a price for each. So the relationship between the pharmacy and the drug is sales. Okay, so let us draw one more relationship here, that is sales. Okay, that is sales. And has a price for each. So attribute is price. So we need to draw one ellipse here, that is price. Okay. We need to link this attribute with the relationship sales. Now, a drug could sold at several pharmacies and the price could vary from one pharmacy to another. Means there is many-to-many relationship between the drug and the pharmacy. Okay. So now we need to link this relationship with the pharmacy. Okay, so I hope you understand the concept of ER diagram and how to draw it. Okay, so just remember there are 4 simple steps. First, you need to identify the entity. Then you need to identify the set of attributes corresponding to that particular entity. Then you need to add those attributes to the entity. Then we have to find the relationship among the entities, and then we need to add the cardinalities between them. Okay, so if we follow these 4 simple steps, we can draw any ER diagram. So if you have any question regarding this, you can ask us in our Discourse forum. Okay, thank you.